Hello everyone, welcome back to my channel. So in this video we will solve some problems on wave propagation. Okay, if you are first time to my channel, please consider subscribing and hit the bell icon to get video notifications from my channel. Right, well, let us see the first question. So this is the first question. He has asked to find the value of the propagation constant. Okay, that is he is asking the value of gamma. Right, for the material having mu r is equal to 1, that is relative permeability is 1 and epsilon r is equal to 8, relative permittivity is 8 and sigma conductivity is 0.25 picosiemens per meter and frequency is 1.6 megahertz. Okay, so he has not given you the medium here, right? So if you have the type of medium, so based on the medium you can substitute the formula for gamma. Okay, so you can have the formula for gamma. I have already discussed you different types of medium, right? Their characteristics, their formulae, everything I have discussed in my previous videos. Okay, so if you have the type of medium, then you can depending on the type of medium you can tell the formula for gamma, that is you will have the formula for gamma. So based on gamma value you can obtain the propagation constant. Okay, so the first thing what you have to do in such type of problems is to find the type of medium. So how we are going to find the type of medium? Based on sigma by omega epsilon, that is loss tangent formula. Okay, so first of all you have to calculate this value. So let us calculate this. So what is sigma? 0.25 picosiemens. So it is 10 to the power of minus 12 divided by omega is 2 pi into f. F is 1.6 into 10 to the power of 6 into epsilon. Epsilon is equal to epsilon naught epsilon r. So epsilon r is 8, so it will be 8 epsilon naught. So 8 into epsilon naught value is 8.854 into 10 to the power of minus 12. Okay, so if you calculate all these values, okay, so after calculating all these values you will get around 3.51 into 10 to the power of minus 10. So you just check it out, okay, in your calc you just check it out. So you'll get the answer like this, 3.51 into 10 to the power of minus 10. So 10 to the power of minus 10, it is very much less value, right? So this value is very much less than 1. Yes or no? So this is 10 to the power of minus 10. So this value is very much less when compared to 1. So sigma by omega epsilon is very much less than 1. Okay, so what is that medium? Then it is lossy or good dielectric medium. Okay, so during this concept of lossy or good dielectric medium, so wave propagation in lossy or good dielectric medium, I have told you that the condition for this medium is, this type of medium is sigma by omega epsilon is less than 1. So now we have got sigma by omega epsilon is less than or equal, very much less when compared to 1. So the medium is lossy or good dielectric. So in this medium, when the medium is lossy or good dielectric, right? So when the medium is this, so what is the formula for sigma? What is the formula for alpha? We have got propagation constant, because we want to find propagation constant. So gamma. So gamma is again combination of alpha and beta. Gamma is again the combination of alpha and beta. So alpha is given by sigma by 2 root of mu by epsilon. Okay, sigma by 2 root of mu by epsilon. So what is sigma? 0.25 into 10 to the power of minus 12 by 2 into root of mu. Mu is mu naught mu r. So mu naught into mu r value is 1 by epsilon. Epsilon is epsilon naught into epsilon r. Epsilon r value is 8. Okay, so 0.25 into 10 to the power of minus 12 divided by 2 into root of 1 by 8 into root of mu naught by epsilon naught. Okay, so we know that root of mu naught by epsilon naught is 120 pi. Okay, so during this free space propagation I have told you that this value is 120 pi. Okay, so 0.25 into 10 to the power of minus 12 into 120 pi I am writing. Okay, so this value I am writing on the numerator side. So in the denominator what is left over? 2 into, so 2 into 2 root 2, root 8 is 2 root 2, so 120 pi here. Okay, so this is the, so if you solve it using Cal C, so you'll get 1.6 into 10 to the power of minus 11. 1.6 into 10 to the power of minus 11. So this is Nepper per meter. Nepper per meter. Second, we have to find beta. So what is the formula for beta? Beta is omega into root of mu epsilon. Omega is 2 pi f. 2 pi into f is 1.6 into 10 to the power of 6 root of mu naught mu r. Mu r value is 1, right? So because mu is equal to mu naught into mu r, epsilon is equal to epsilon naught into epsilon r. So epsilon naught I am writing as it is. Epsilon r value is 8. Okay, so 2 pi into root 8 into 1.6 into 10 to the power of 6 into root of mu naught epsilon naught. Okay, so we know that 1 by root of mu naught epsilon naught is velocity of light, that is 3 into 10 to the power of 8. 3 into 10 to the power of 8. So we have root of mu naught epsilon naught, so it will be 1 by 3 into 10 to the power of 8. So 2 pi into root 8 into 1.6 into 10 to the power of 6 divided by 3 into 10 to the power of 8, because root of mu naught epsilon naught is 1 by 3 into 10 to the power of 8. Okay, so if you solve this, you will get around 0.09478 radians per meter. Okay, so the combination of these two, so alpha plus j beta is your gamma. Okay, so you just write that at the last. So gamma is equal to alpha. Alpha is 1.6 into 10 to the power of minus 11. Alpha plus j into beta. Beta is 0.09478, right, per meter. Okay, so this is how we can find the propagation constant for a given data, right? So from the data, if you don't want, if you are not given with the type of medium, you have to find the type of medium by using the concept of loss tangent. Okay, so this model is very important. Okay, so next we'll see one more simple problem. Right, so he is asked to find the wavelength of the wave with propagation constant. This is okay, so he has given one propagation constant, so he has asked to find the wavelength. Okay, so from propagation constant, so gamma is equal to 0.1 pi plus j into 0.2 pi. So alpha is 0.1 pi, so real part of this gamma is called as attenuation constant alpha, which is in Nepper per meter, and imaginary part of this gamma is called as beta, the phase shift constant, so it is 0.2 pi radians per meter. Okay, so we have got the alpha and beta values from the given value of gamma. So once you got the beta value, so lambda is 2 pi by beta, so wavelength is 2 pi by beta, so it will be 2 pi by 0.2 pi, so pi and pi gets cancelled, so it will be 10 meters. Okay, so very simple problem. So this type of questions may also be asked. Okay, so next we'll see the next problem, right? In this problem he has given some electrical parameters at a frequency. Okay, so all these electrical parameters he has given and he has asked you to find the type of material, that is type of medium, of course. Okay, so what are the parameters he has given? Frequency is 10 gigahertz, right? Sigma naught is 10 to the power of 6 mho per meter, and mu is equal to mu naught. Sigma is equal to 10 into sigma naught, so 10 into 10 to the power of 6. Okay, so mho per meter. So epsilon naught is 1 by 36 pi into 10 to the power of minus 9 farad per meter. So all these values he has given. Okay, right, so he has not given any value of epsilon r and mu naught, so we'll consider them as 1. So mu is equal to mu naught, so mu is equal to mu naught, that is mu r is equal to 1. So when mu is equal to mu naught, it is a non-magnetic material. Okay, so material cannot be magnetic, non-magnetic material when mu is equal to mu naught. So remember this point. So when mu r is equal to 1, it is a non-magnetic material. For all other materials, you will have some value for mu r other than 1. Okay, so good magnetic material is a wrong option. It is not at all a magnetic material. Okay, right, so in order to find whether the given material is either good dielectric or good conductor, you have only one chance, that is loss tangent again. Sigma by omega epsilon you have to find. Okay, what is sigma value? 10 into 10 to the power of 6. 10 into 10 to the power of 6 divided by omega. So omega is 2 pi f. 2 pi into 10 into 10 to the power of 9. Right, gigahertz. So 10 to the power of 9 into, right, so epsilon r is 1. So epsilon is epsilon naught. So epsilon is epsilon naught, 1 by 36 pi into 10 to the power of minus 9. So 10 to the power of 9, 10 to the power of minus 9 gets cancelled, 10 and 10 gets cancelled. Okay, so pi and pi also gets cancelled. So what is left over? 18 into 10 to the power of 6. 18 into 10 to the power of 6. So this value is very much greater than 1. So sigma by omega epsilon, sigma by omega epsilon value is very much greater than 1. So it is very much greater than 1. So it is a good conductor. That's all. So the medium is a good conductor medium. Okay, so while discussing about good conductor medium, I have told you that this condition, if this condition is satisfied, then the medium is a good conductor medium. So here the answer is option B. Okay, so this is how we can find the type of medium. Okay, so next we'll see one more problem, the last problem for this video. Okay, so fourth problem. In this problem, he has asked to find the value of propagation constant. Okay, so that means gamma he is asking. He is asking to find the value of gamma and phase velocity also. So Vp also he is asking us to find. Okay, so the data given for you is frequency, which is equal to 500 kilohertz. Okay, so 500 kilohertz, and also mu r value is 1, epsilon r value is 15, and sigma is equal to 0. Okay, so when sigma is equal to 0 and mu r and epsilon r are having some values, right, they are not equal to 1, then what is that medium? So when sigma is equal to 0, you have only two options. One, for free space sigma is equal to 0, or for perfect or lossless dielectric sigma is equal to 0. And for free space, epsilon is equal to epsilon naught only. But here there is some value for epsilon r, that is epsilon is equal to epsilon naught into epsilon r, you have to consider. And similarly mu is equal to mu naught into mu r. So all these three conditions are satisfied for which medium? So it is that, thus from the given data we can have the inference, that the medium is perfect or lossless dielectric, perfect or lossless dielectric. Okay, so this inference we have got from the given data only. Okay, so in this case no need to find the loss tangent value because directly sigma is equal to 0. Okay, so when the medium is perfect or lossless dielectric, so I have already derived the formula. So first of all we have to find the value of Vp. So Vp is C by root of mu r epsilon r. Okay, so this formula already I have derived. Okay, you can check my previous video of wave characteristics in perfect or lossless dielectric medium. Okay, so C is 3 into 10 to the power of 8 divided by root of mu r is 1, epsilon r is 15. Okay, so if you find using calc, so you'll get 7.745 into 10 to the power of 7 meter per second. So this is the value of phase velocity. So when sigma is equal to 0, automatically alpha is equal to 0. So in the case of perfect or lossless dielectric, if you see, so alpha is equal to B0, and we have only the value of beta. So what is the value of beta? Beta is omega into root of mu epsilon. Omega into root of mu epsilon. What is omega? Omega is 2 pi into f. F is 500 kilohertz. So 500 into 10 to the power of 3. Root of, what is mu? Mu naught into mu r. Mu naught mu r, epsilon naught epsilon r. But what we have is 1 by root of mu naught epsilon naught value is velocity of light, that is 3 into 10 to the power of 8. So root of mu naught epsilon naught value is 1 by 3 into 10 to the power of 8. Okay, so substituting that, what you'll get? 2 pi into 500 into 10 to the power of 3 divided by, so root of mu naught into epsilon naught, I am writing root of mu naught into epsilon naught as 1 by 3 into 10 to the power of 8. So 1 by 3 into 10 to the power of 8, so I am writing in the denominator, into root of mu r epsilon r. Root of mu r is 1, epsilon r is 15, so 1 into 15 is 15. Okay, so if you solve for this, you will get around 0.04 radian per meter. 0.04 radian per meter. And here is asked to find the propagation constant gamma. So since alpha is equal to 0 for perfect or lossless dielectric, so perfect or lossless dielectric medium, so alpha is equal to 0, right? Alpha is equal to 0, so gamma is equal to j beta only, right? So j into 0.04 per meter. So this is the value of propagation constant. Okay, so this is how we can find, based on the type of medium, we can find different characteristics of that medium. Okay, so for all this you have to remember all the formulas for each and every type of medium. Okay.